Dear students, welcome and thank you for tuning in to this video. I'm Dr. Lyle Zobi and we are continuing our discussion about medical signals and image processing. In this lecture, I will be talking about another tool for image enhancement, which is order-statistic filters. And to recall what we have covered so far, we were talking about image enhancement, and in the previous lectures we talked about spatial filtering, intensity transformation, image histograms and equalization, as well as all the convolution filters, which are the smoothing and sharpening and edge detection. In this video I will be covering order-statistic filters and what they are and how do we use them and why. So the first thing I would like to talk about is that order-statistic filters are non-linear spatial filters whose response is based on the ordering or ranking of the pixels contained in an image area encompassed by the filter. And if we recall from our schematic, we said that we will have a kernel matrix like this one, and I have my original image, and we have each square or box here. Each square is a pixel, and we are talking about selecting values for the kernel matrix. For the static or the order-static filters, we are going to be looking at the image itself, our image, and we are going to look at the values in our image that are corresponding to the kernel matrix window that we are interested in. And what we'll be doing is ordering the values of the pixels here. And if this is a grayscale image and an 8-pixel grayscale image, we will have values between 0 and 255. So I will be looking at the numbers in this window, and I will rank them ascending or descending, and then we will be doing the filtration. For example, here this is part of an image, which is a 3x3 section of the image. And the first thing about order-statistic filter that we need to do is we would like to sort the pixel values inside this matrix, and it doesn't have to be a square matrix. It could be with any dimensions from your original image. So this is not a kernel matrix, this is the original image. And what we do is that we're going to sort them ascendingly, so from 1 till 11, that's the maximum grayscale value of this part of the image. And then what we do is the response of this class of filter depend on the ordering of the pixel values that we would like to do. So, and after that I would be replacing the center pixel, the value of the center pixel with the value determined by the ranking result. So if I would like to replace here, in this example it's 4, I can replace 4 with the minimum value, which is 1, or with the maximum value, which is 11, or with the median value. And I'm going to explain what does that mean and how do we use this filter. So the first thing we'd like to look after sorting the pixel values, and we rank them with the minimum, and we would like to use the minimum value here. And the minimum value, it's going to be the darkest point on our image in the grayscale, depending on your image. So 1 here is the darkest value, and if I'm looking at this part of the image, our image with the grayscale values, I would like to replace 4 with 1 with the darkest value. And this is we call this order-statistics filter, min filter, and I'm going to replace the center pixel with the minimum value of the ranks of the ranking, the minimum value from the ranking, the ascending ranking. And usually we will have something in an image, a noise called salt noise, and the salt noise is that like white dots. And what we will be doing is replacing the middle pixel with the darkest value to eliminate the salt noise. And it's called salt because it's like white grains or dots in your image. Also, you can do the other way around. You can say, well, okay, I'm going to replace the middle pixel with the largest value of the grayscale, and which is here the brightest point. And this is called elimination of pepper noise, similar to the salt noise, where we have white grains in our image. The pepper noise is like black grains or dots in our image, and I can eliminate that by using the order-statistic filter, which is the max filter, and replacing the middle pixel with the highest value of the grayscale, which is 11 of this window of the image. Also, we can use the median filter instead of the min and max. And the median filter here is eliminate the of general impulsive noise in an image, and it is really good filter where it will produce an image with less blurring than linear smoothing filters than the ones that we learned about in the previous videos. So these are the three different types of order statistic filters, and if I want to show you examples of how do we use them, just keep in mind that in these filters, in the order static filters, we are not using a matrix, a kernel matrix. Instead, we are using the values of the original image, the values in the pixels of the original image, and then we sort them and we replace the middle pixel with the value, if it's the minimum, maximum, or the median value, depending on that, of what we want to do on our image. So, for example, if you look at this original image here, and we've added, salt noise, and you can see that this by the white dots, that's called salt noise. And I would like to get rid of the salt noise. Remember that in the grayscale pixel, the larger the grayscale value or the pixel value in the grayscale from 0 to 255, if it's 8 pixel a grayscale image, so the larger the value, the closer to 255, the brighter it is. So I have a lot of bright values here, and when we do filtration for in this image, I can use the min. I can use the order statistic filter min, in which I'm going to replace the middle pixel with the lowest value. So what we do is that we come here, we select a part of the image, and I will find the middle pixel and I will replace it with the smallest value, and that replace it with the smallest value of the ranks, which is actually the darkest value, the darkest pixel. And this way I eliminate all the white dots from my image, and that's how we use the min filter, the order statistics min filter. And that's a demonstration of how that works. So our original image, that's when we have the noise, which is the salt, and this is when we remove the salt, and you can see that it's a little bit darker than the original one, because we have a lot of dark points in the middle. Now, on the other hand, if you have salt and pepper noise added to your image, so this is our image, and I have white dots and also black dots, and I would like to get rid of both of them, I will use the median filter, the order statistic median filter, in which I will be replacing the middle pixel of my window here with the median value of the grayscale pixels. And that's how we get rid of the positive, the white and black, salt and pepper noise, and we get our image back how it should be. The last example I would like to show you is also if you have an image, and then we have also Gaussian noise added, and then also we can use the median filter to clean that Gaussian noise that we have in our image to get this a much more concise image, and much better image to look at rather than have a Gaussian noise. And that's why people like to use the median filter, because it is really an effective filter, as we mentioned before, and it eliminating the general impulsive noises, as well as it will has less blurring than the smoothing filters. So I hope this video clarifies how do we use order static filters. So we took a part of our image, or a matrix of our image, grayscale, order them, and then replace the middle pixel with, if it's a 3x3, we replace the middle pixel with the largest or the smallest grayscale, or the median value of the grayscale. If you reach this point, thank you for watching. Hopefully this was helpful. If you have questions, don't hesitate to write them in the comment section below, and I'll be more than happy to answer them for you. Thank you for watching. Until the next video. Bye.